Good morning, Dunlap family. Welcome back to another day of math. We are continuing working on line plots, and we will get to that in just a minute. But let's start with checking your morning work first. So, have out week 26. We are checking day 3. So here we go. Each person at a party will eat 2/3 of a pound of turkey, and 8 people will be at the party. How many pounds of turkey will be needed? All right, so here we go. 8 people, and each person is going to eat 2/3 of a pound. So I've got 8 people. Each person is going to eat 2/3 of a pound. We're trying to figure out how much turkey is going to be consumed at the party. So basically I've got 8 groups of 2/3. Because each person is going to eat 2/3 of a pound of turkey. So I'm going to have to do that 8 times. So let's see, 1, 2, 3, 4, 5, 6, 7, 8. Woo! There we go, I squeezed them in there. 1, 2, 3, 4, 5, 6, 7, 8. So I have my 8 groups of 2/3. 8 people, each person's eating 2/3 of a pound of turkey. So if I do all of that and I add them all up, let's add them up. 2, 4, 6, 8, 10, 12, 14, 16. I get 16 thirds. Can I keep it like that though? Is that my final answer? No, because this is an improper fraction. So now I have to start pulling out whole numbers. All right, so let's think about this. I have one whole number. I'm going to do another one. Yep, because now I'm up to 6. I'm going to try to get to 16. Can I do another one? No, that's 9. How about another one? That's 12. Can I do another one? Yep. Because now I have 15. Let's check. 3 plus 3 is 6, plus 3 is 9, plus 3 is 12, plus 3 is 15. So I have 15 thirds, which means I've got one more third to get to 16. So how many holes is that? 1, 2, 3, 4, 5 holes, and 1/3. Okay, so if I have 8 groups of 2/3, that's going to equal 5 holes and 1/3. So my final answer is 5 1/3 pounds of turkey will be eaten. Okay, so there you go. That's the first one. Let me make some room for the second one. Number 2, so we have 2/10 plus 5/100. So can I read it? Can I add it like it is right now? No, why not? Your denominators are different. Can't do that. So I have to make them the same. No problem at all. You're going to make this one have the same denominator as this, and you can do that. You know how to make that an equivalent fraction. Alright, so if I go from 10 to 100, I'm going to multiply by 10. So that means I do my numerator, multiply that by 10. So 2 times 10 is 20. So 20 hundredths is the same as 2/10. So look at that, 20 hundredths. Now my denominators are the same. Now I can add them, and when I add them up, I get 25 hundredths. Any idea how to write that as a decimal? How do I write 25 hundredths as a decimal? Because it means the same thing. Decimals and fractions both talk about parts of a whole or show parts of a whole or parts of a group. So if I want to write it as a decimal, I'm just going to do decimal point 25. 25 hundredths, 25 hundredths. Exact same thing. All right, next one is an addition review question. So we have 25,694 plus 15,507. Okay, so when I add, always start with my ones column first. 4 plus 7 is 11. I have to regroup my 1. 1 plus 9 is 10, plus 0 stays 10. To regroup. 1 plus 6 is 7, plus 5 is 12. Regroup. 1 plus 5 is 6, plus 5 is 11. Regroup. 1 plus 2 is 3, plus 1 is 4. So my sum is 41,201. The last one is to decompose 9/12 in two different ways. There are a lot of ways you could do this. To be careful though, because on your problem it only lets you do 2 boxes. So these 2 boxes have to come up to be 9/12. Okay, so that limits you a little bit. You could do 1/12 plus 8/12, or you could do the opposite, 8/12 plus 1/12. You could do 2/12 plus 7/12, or flip it, use the commutative property. You could do 7/12 plus 2/12. You could do 3/12 plus 6/12, flip it, 6/12 plus 3/12. Or you could do 4/12 plus 5/12, or flip it, 5/12 plus 4/12. So any of those would work. Any of those would work. All right, I think that was the last one. Right, that's it for your morning work, so good job. All right, so I'm going to make room up here because we're going to kind of transition and do line plots. So you're going to put me on pause. You're going to grab a piece of scrap paper and a pencil if you don't have one already. And then also you're going to need open that Envision pages 599 and 600 that I sent to you. So you're going to pause me for a minute, get out your things, have things open. Are you ready? I'll say it again. You're going to pause me, get out scrap paper and a pencil, and then make sure you have open in a separate tab. You're going to have to go back to Google Classroom, pull up the Envision pages I sent you. It's 599 and 600. All right, so go ahead and pause me. When you're ready, come back. Ready? Go. Okay, so hopefully you have everything in front of you. Scrap paper, pencil, and then you have those pages from your Envision book pulled up, 599 and 600. All right, so if you look at the very bottom of 599, you're going to see a blank line plot. That's where we're going to be focusing on. All right, we are continuing on our learning target. I can answer questions about data measured on a line plot. Today, if I get more specific, is I can create a line plot given a set of data. So you are going to be given the data. You are going to create the line plot. You are going to determine what it's going to look like. Okay? So if you look down at the bottom of 599, you're going to see something similar to this. Length of Rico's bracelets. You're going to see the number line. They already have that ready for you, and the title or the label inches. So this lets us know this is the information that we're going to be looking at. This is the unit of measurement that we are using, and then part of the number line. All right, remember the arrows show us that they go on and on and on. We're just focusing on a small part of the number line that matches the data that we are going to be looking at here in just a second. Okay, so I go from 6 to 9. What am I counting by? How do I go up? I'm going up by ½ an inch every time. So I start at 6, and then I go 6.5, 7, 7.5, 8, 8.5, 9. Okay, you don't always have to use ½ inches, but let's look at the data. Look at the bottom of 599. It says bracelet lengths, and if you look at that data chart, those lengths come in ½ inches. So our number line has to use ½ inches as well. So whatever your data says, that's what your number line is going to have to say. If it just uses whole numbers, then you just use whole numbers. But if it has fractions in it in your data set, then you're going to have to use fractions on your number line. Okay? One other thing I want to point out is if you have fractions in your data set, you have to use fractions all across. So for example, let's say that I didn't have any 6.5. I wasn't 6.5 on my chart, but I had 7.5 and an 8.5. Then I have to count by halves the whole way. I can't just pick and choose where I throw a half in. Does that make sense? So even if you have 1/2 somewhere in your data set, then you need to go halves the whole way. So it's consistent and it's the same. You're counting up by the same every single time. Does that make sense? I hope. It's hard to tell because I can't see your faces. All right? Let's take a look at the data set. Look at the bracelet lengths. Okay? You've got 2 columns of bracelet lengths. Here's what you're going to do. In just a moment, you're going to pause me and you are going to copy this down. So when you pause me, make sure you can see this. Okay? You're going to create your own line plot. Go ahead and copy this information down. And then you're going to look at your data set, the bracelet lengths at the bottom of 599, and you're going to plot those with your dots where they belong. Do yourself a favor. When you're looking at the data, don't go and try to count all the sixes. Don't go 6, 6, 6, 6. There's 4 sixes. I'm going to put 4 dots. Please don't do that. That's going to confuse you and you're going to miss something. The way to do it is you go down your column. So you're going to plot 8, 6.5, 7.5, 8, 6.5. That way you won't miss any. Does that make sense? Go down your column and then go down the second column. And when you're done, your line plot will be completely filled in. Okay? So in just a second, you're going to go to pause me, copy this part down, or you can use page 599. It's the same one. Take that data set and plot it. And then when you're all done, come back and check with me and see if yours looks like mine. Okay? You ready? You got this. Go. All right. Do you have your line plot ready to go? Take a look at yours and compare yours with what mine is and see if yours looks the same. All right? We had no 6-inch bracelets, but we had 1, 2, 3 for 6.5. 0 for 7, but you should have 2 dots above 7.5. Above the 8, you should have 4 dots because 4 people needed 8-inch long bracelets and 1 needed 8.5. Okay, so by looking at your line plot, what was the most common bracelet length? Which one was most common? Well, 8 inches would have been most common because we needed 4 people needed that length bracelet. Okay, only 3 needed 6.5 and we have 2 and 1. All right, do we have any outliers? Do we have any outliers on this line plot? No, we don't. They're all pretty much within the reason. I know this kind of looks like maybe, but not really. Look, it's only an inch away. So that's really not an outlier. If it was an outlier, we'd be talking like, like 12 or 13 way down here, or like 2 or 3 way down here. It's going to be a huge difference. Those are outliers. So no, we don't really have any outliers on our line plot right now. Okay, so how long was the longest bracelet? The 8.5 inches. Okay, how short was the shortest bracelet? 6.5 inches. How many inches would there be between 6.5 and 8.5? Can you do that one in your head? Remember I told you about counting up yesterday? 6.5, 7.5, 8.5. There would be 2 inches. 2 inches difference between these two. Okay. How many more people needed an 8-inch bracelet than a 7.5-inch bracelet? I'll say that again. How many more people needed an 8-inch bracelet than a 7.5-inch bracelet? Well, we have 4 people here and 2 people over here. So how many more needed an 8-inch bracelet? 2 people. 2 more people. Nicely done. Here's what I need you to do. Go scroll down to page 600. And I want you to look in the middle of page 600, there is number 8. You're going to make a line plot. Okay? You're going to use the data that's there, that little girl's holding up, day and time. All right? You're going to make your own line plot using that data. And you're going to share that line plot with me in small groups today. Okay? So I'll say it again. 600, get some scrap paper out. You're going to look at number 8. All right, and you were going to create your own line plot using the data that she's holding. Now be careful, it's more than just this part right here. Look what else you need. You need a title for your line plot, you need a label for your line plot, and then you need a line, number line, and then your data. So there are lots of parts to it. Make sure yours has every single part that you need. Okay, and then I would love to see them in small groups and we'll talk about them. All right. Thank you for listening. I will see you in a little bit. Love you. Bye.